All right, hey y'all. Sorry. Today's objective is point ratio form. Maybe you've heard of point slope form before, and that is when you have 2 points and you are going to use those 2 points to find the like point slope form. You can use 2 points to find the slope, or you can use a pair of points in the slope to find the equation of a line. Anyways, point ratio form is a little similar. You're going to be given 2 points, and you're going to use this equation to find the common ratio. We've been talking about exponential functions, and we know that the common ratio of b, that base. Well, in our problems right now, you're going to be given 2 points, and you're going to have to find b, find a, and then write the equation. So the exponential equation, it looks like this. Y equals ab to the x power. A is your initial amount, your starting amount, when x is 0. B is your base, your rate, whatever that letter, your common ratio. And then you have your x and y, your exponent and your y. So we're going to plug values in for x and y. We're going to solve for b. Then once we have b, we're going to solve for a when x is 0. All right? Example 1, use point ratio form to write the equation, and y equals abx, y equals abx. So first we need to find b, then we need to find a. To find b, we have 2 points, 2, 8, and 5, 19. These are 2 points that lie on an exponential curve. We have to plug them into our formula, y equals y1 times b, x minus x1. I have plugged in, as you see, 8 in for y and 19 in for y1. So there are my y values. Then I plugged in 2 in for x and 5 in for x sub 1. I simplified 2 minus 5 and I got -3. Now I'm going to simplify, and this is where solving equations with rational exponents comes in. So I'm going to divide both sides by 19. And 8 divided by 19, sorry, I have to get my calculator. Eight divided by 19 is, some long decimal. I think I'm just going to leave it 8 over 19 for right now because it's some long decimal. And then to undo this -3rd power, we're going to raise it to the -1/3 power, because remember, we want our exponents, when you multiply those, to be a 1. That's how you're going to solve this. You want an exponent of 1. I have to raise this to the -1/3 power. And when I type that in, 8 over 19 raised to the -1/3 power, I get 1.3342. And then some zeros. So I'm just going to stop right here. 1.3342000824. So here's my b value. Now that I have found b, I need to plug it back in to find a. To find the initial starting amount, a, is when x equals 0. That is your initial amount, your starting amount to find a. So we are going to plug in, we're going to use this point. And then we're going to use x is 0, and then we're looking for that value right there. So we are going to say, sorry, 0, when x is 0, and we're looking for a, that's y. We are going to use y equals y1, let's just use 8, times b, we just found b, 3342, raised to the 0 minus 2 power. So let me make sure you understand. Where x and y are, we're using 0, comma y, because this is our starting, this is our initial value. When x is 0, that's your initial value. We're plugging in y1 and x1 with 2 and 8. So 8 went in here, 2 went in here. And then we use b, this value for b. So now I can simplify 0, 8 times 1.3342 to the negative 2 power. And I can type that into my calculator, 1.3342 to the negative 2 power times 8. And that gives me 4.94, whoops, 4.4942. And that is my initial value. So, to wrap it all up, now that I found my initial value, that's like my A, I can rewrite it this way. Y equals 4.4942 times B, 1.3342, raised to the x power. That was a lot. I never said it was going to be easy, so let me just verbally go through it again. I used my equation, I substituted my points in, and I found B. Once you find B, you're going to take one of your points. I just took the first one, 2, 8. And we let x equals 0 to find y. That is your initial value. That's your starting amount when x is 0. Then I plugged it over here. I used 8 and 2. So here's my 8 and here's my 2. And then I used my B value. I solved all that and I got y. Then once I plug that in, that's my A, so this is my initial value, this is my B, and then I have x and y. How about we do another one? Alright, use point ratio to write an equation in this form, y equals a times bx. So I have 2 points, 2, 12.6, 5, 42.525. First thing we need to do is find b by plugging it into our point ratio formula. So notice y, y1, x, x1. Now I'm going to simplify my 2 minus 5, and that's going to give me negative 3. So I have 12.6 equals 42.525 b to the negative 3rd power. I have to divide both sides by 42.525. And b to the negative 3rd is 12.6 divided by 42.525. And that is equal to, 0.29629. So I think it's repeating. 0.296296296. To solve this, to undo that negative 3rd power, I'm going to raise this to the negative 1/3. Because these two exponents, if you multiply negative 3 times negative 1/3, those would multiply to be a positive 1, which is what I want, b to the 1st power. When I raise this to the negative 1/3, raised to the negative 1/3 power, I get 1.5. So b is 1.5. Now, I have found b. So I have to use b back in this formula. And I need to use a point, so I'm going to use this one because this one's easier. And I have to use the point when x is 0, what is y? Because that would be our initial amount, our starting amount. So I come over here and I put in y, and y1, 12.6 times b, which is 1.5, and then x, which is 0, minus x1. I can simplify this to negative 2. So I need to do 1.5 to the negative half power, 1.5 to the negative second power, times 12.6. And y is 5.6. So let me tell you, I typed this into my calculator first. 1.5 to the negative second power, and I got 0.4 repeating. And then I did 0.4 repeating times 12.6. Now that I have, this is my initial amount, my A, I can write it in this equation. Y equals A, 5.6, times B, 1.5 raised to the x power. So this one might be better looking in parentheses since there's so many decimals. Whew. Again, a long problem, not easy, but again, you are in math too. All right, so write this down. The intensity of light decays exponentially with each additional colored gel added over a spotlight. With 3 gels, there's 900 watts per centimeter squared. After 2 more gels, there's 600 watts per centimeter squared. Hey. Thank you. Okay. Okay, sorry. 600 watts per centimeter squared. Write an equation in this form. What's the intensity after 7 gels? So you can see I've set up my 2 points, 3 and 900, and then I have 600. But when it says after 2 more gels, you have 3 gels, and then you have 2 more gels, that would be 5 and 600. Seems like they're all 3 and 5. That's interesting. Now, we need to use our formula right here. So I'm going to set it up. Y, which would be 900, equals 600, B, and then 3 minus 5. 3 minus 5 is going to be negative 2. So I am going to divide by 600, and I get b to the negative half power. And 900 over 600, it's going to be a repeating decimal. Oh no, 1.5. Whoops. To undo a negative square power, we're going to raise this to the negative 1/2 power. So my exponents can multiply to be a power of 1. And I get b, so 1.5 raised to the negative 1/2 power. Oh, yep. All right, 0.81645. 0.8165. Really, it's 0.816496, so I just rounded. We found B. Now that we have B, we have to find A. So I'm going to take B. I'm going to take a point, 3, 900, and 0, Y, to plug back in. So Y equals Y1, which would be 900, B, which is 0.8165, and then X, 0 minus 3. 0 minus 3 is the negative third power, so I'm going to do this first. 0.8165 to the negative third power. And then I'm going to multiply that by 900, and we get 1,653.385. That would be your initial value. That would be your initial intensity. So if you have 0 gels, like in this real world problem, 0 gels would give you that intensity, watts per centimeter squared. That is your initial amount. Therefore, we can write our equation, y equals our initial amount, 1653.385, times our ratio, our common ratio, 0.8165 to the x power. Here is our equation. All of that to find the equation. The question also states, what is the intensity after 7 joules? So we would substitute in right here as 7. 1653.385 times 0.8165 to the 7th power. It should be smaller than 600 because it's a decay. It decays. So I'm going to type in 0.8165 to the 7th power times 1653.385, and it's 400 watts per centimeter squared with 7 joules. Now that was a lot, and I'm not denying that that was a lot, but we have one more. So I want you to copy this down. Example 4, the number of snakes on Guam grows exponentially. Woo, snakes. In 1945, there was 1 snake. In that's not supposed to say 45. That is supposed to say 45. This is supposed to say 1949. Oh, hold on. 1945. So in 1945, 1 snake. In 1949, there were 625 snakes. How many snakes will there be in 1955? So in order to solve this, we have to come up with the equation y equals abx. So here's where I want you to try it on your own. I want you to use our formula, y equals y1 times bx minus x1. And your points. This is your starting year, so that would be 0. And your year obviously is your independent variable. And there was 1 snake, so that is your y. So your first point is going to be 0, 1. In the starting year, the first year, well, the starting year, the initial year is 0 years, there's 1 snake. Then from 1945 to 1949, that is 4 years. 45, so 46, 47, 48, 49. 4 years. And there were 625 snakes. So here are your 2 points. I want you to substitute your 2 points in and see if you can find B. After you find B, I've actually given you A. Here's your A value right there. There's your initial A value. So you already have your A. You just have to figure out how many there will be in 1955. So for what I want you to try to do, I want you to try to get your B. If you get your B and you feel comfortable, then go on. But if you get stuck, we will go over this tomorrow.